Direct variation. This is a special type of linear function. Okay, so if it's a linear function, what's my graph look like? A line. Okay, so we're going back to lines with direct variation. Okay. Okay, the K value. Okay, notice it's K now. What is that usually in a linear?
It's the number.
What letter? If I went back to a regular linear function, it's y equals what? mx plus b. So y equals mx plus b. So we've changed what letter in this to K now? M. So K is technically your M. Okay, I'm going to put M right above K. This is called your constant of variation. And it must be a non-zero number. So in other words, I can't have 0 for K. There cannot be a 0 slope. It just isn't going to work.
Goes like, isn't it straight?
Yes.
What's it called when it goes like straight up?
That's x equals a number. Y equals a number is a horizontal line. It goes through your y-axis.
Okay.
X equals a number is a straight up and down. It's a vertical line, and that's x equals a number. It goes through your x-axis. Okay, so what you should be able to do is, if I give you an equation, you should be able to tell me, is it direct variation or no? What do you notice also before we get into that? Let me back up a second. What else do you notice about y equals kx? What's missing? Okay, your y-intercept is missing. Guess what? Your y-intercept is always 0 if it's direct variation.
So this is yes.
Okay.
So
it's always going to be y equals some number, no matter what it is, times k, and there should be nothing added or subtracted if it's direct variation. Okay. It should go straight through the origin, no matter what.
I feel like I'm gonna forget that.
Solve the equation for y, and then tell me, is it direct variation or not? So if I solve my first equation for y, what's my first step?
Move your 2x over.
Good, Muhammad. Move my 2x over. So it has to become negative 2x. So I get 3y equals negative 2x. My next step then, Jeremiah, is what?
Divide by 3.
Divide by 3. We're solving it for y, not x. Divide by 3. So I get y equals negative 2/3 x. Would you say this is direct variation?
Yes. Yes.
Yes. It doesn't matter that k is a fraction. It does not matter that k is negative. There is a value in front of x, and there is nothing added or subtracted. So yes, this is direct variation. Okay. What'd you say, Daniel?
What happens to the y to the 3y equals x, 2 you divide by 3 by the negative 2x, and then y just disappears in the x.
What do you mean y disappears? What?
And the equation, the 2x plus 3y equals 0.
Uh-huh.
You took away 0 and then now change to negative 2x.
Uh-huh.
And then you divide by both sides with a 3y, and then the y just disappears.
We did not divide by 3y. We only divided by 3.
Then what happened to the y and x?
Your y's right here.
Oh, it's just...
We don't divide by 3y. You want y isolated by itself. So you technically, what you're trying to do is get the coefficient in front of y to equal 1. So if I divide 3y by 3, 3 over 3 reduces down to 1, which leaves your y there. So y doesn't disappear. Okay, it's still there. Okay. It's just like solving any of your quadratic equations and making it equal to 0 before you can pull a, b, and c. You just want to get y by itself. Okay.
So it's gonna be
Uh,
Because there's
Okay.
There's the three.
So, Brandon automatically looked at this one and said, this one should automatically be a no.
Yeah.
Okay? There's that plus 3 there.
Exactly.
Okay? So, you are absolutely correct. If we go through and solve this, though, my first step should be subtract 3 from both sides. So, I get 2y equals 4x minus 3.
Yeah.
We divide everything by 2. So, you get, I'm going to write it up here because I ran out of room. Y equals 2x minus 3 halves. Okay? So, that minus 3 halves automatically makes it no direct variation. Yes, Teresa. Okay. You are very smart if I can just get you to do some work. Uh-huh.
Is that I don't do work on paper. I don't like, okay, Jeremiah, you suck.
Yeah.
That's why your parents will like you.
Okay. You should be able to also. Right there is not going to roll with me because I've got to stand here to write. Swing it to the other side and just make sure nobody has an issue seeing over you. All right. You should be able to determine this from a table. So, determine whether or not the table represents a direct variation. It says that I need to take y and divide by x. If the answer is the same for each ordered pair, then there is direct variation. So, in other words, I want to take 10.5 and divide by 3. What do I get?
3.5.
3.5.
It should work.
Okay. Then I'm going to take 17 and a half divided by 5. That's my second ordered pair. Okay. That comes out to be what? 3.5. And then 28 divided by 8 is also 3.5. So yes, this is direct variation. So if they give you a table, you can also find direct variation.
It's also
like
linear.
what the number is, as long as they're all the same. Right? Like what
Huh?
it is. As long as the numbers are all the same, does it matter what it is? Like,
No.
it could be
So like
that-
I could have done, we could have done like 2 and 4. So then that would have been 4 divided by 2 gives me 2. And then we could have done like 8 and 4. Well, 8 divided by 4 is 2. Now, be careful. You need to check every one. So you see a pattern happening here. That doesn't mean that they can't screw with you at the end and put like 12 and 6. Or, yeah, not 12 and 6.
Mhm.
Wrong.
12.
12 and 8.
Oh,
Okay? They will do that. Do not stop. Check them all. Because when I do 12 divided by 8,
it's like,
it becomes
like 1.5.
3 halves and not 2. Okay? So it doesn't matter what the number is. It just matters if they're all the same. And your numbers could also be negative. That's okay. As long as they're all the same. So check every last one of them. Okay? The last thing on here. Write a direct variation equation. Okay? So now, I need to solve for k. So direct variation is always y equals k times x. It says the value of y varies directly with x. So that automatically tells you when it says the value of y varies directly with x. That means y equals k times x. Okay. That's what tells you that you're using direct variation. It varies directly. Okay. Now, they're going to give you values for y, they're going to give you values for x. You need to plug those in and find k, and then give me an equation. So, my y is 4. So my y is going to be replaced with 4. I don't know what k is, but I know x is 8. I need to get k by itself now. Divide both sides by 8. So what does k equal?
1/2.
1/2. So now it says write me an equation. So my actual equation is y equals 1/2 x. Questions?
And that's your next one.
Hmm?
Linear, you put that.
Yes, that's a linear equation. So you could go ahead and even graph this now. This means that I've got a y-intercept at 0. Remember, direct variation always starts at the origin, and then my slope goes up 1 to the right by 2. Up 1 to the right by 2. So that would be your line.
Stairs.
Or you graph it on your calculator. All right.
These should be pretty easy, right?
These should be pretty easy.
Let's do that, and you're gonna give us the hard stuff you did.
I'm going to give you the hard stuff. Listen on page 92, please, and get out your last one for today. And then I'm going to break you off into groups.
It's gonna be like 10, 15 to like 40,000.
Can you believe we're gonna be at page 100?
Can I believe you're going to be a what?
Page 100.
On page 100 soon. I know. We should do a page 100 party, like the 100th day of school party.
Yeah, we already tried that. We were like,
Oh, my.
our school stuff. I went to Southwest.
Woo. Whoa. All right.
I don't remember that.
Okay. I'm under the first flap. If you didn't cut flaps, that's okay. I'm at the what's it look like from a table. Okay. I'm clear on the left-hand side of that foldable. Everybody with me?
Yeah.
Okay. It says a direct variation between two quantities is a relationship in which the ratio, okay, a ratio is a fraction, which is why we divide y by x, okay, of one quantity to the other is constant. What does constant mean?
It's all the
Same.
same.
Okay. If everything's constant, that means it's the same. Okay. So we're going to do just what we did on the last one and recognize this direct variation from a table. So in order to do that, we need to do y divided by x. So what's 6 divided by 1? 6. What's 12 divided by 2? 6. What's 18 divided by 3? 24 divided by 4. 36 divided by 6. Is this direct variation? Yes. Okay. Try B, C, and D on your own before we go over it. Oh, I know, I'm making you do work. Try it. Okay, gentlemen, I see that you're on your calculators on your phones. No, there are calculators provided in this classroom. I will take your phones. Get off of them and go get yourself a calculator. I told you that before, Jeremiah.
We'll get to the very top of the question.
The line at the top, constant.
Okay, thank you.
You're welcome, sir. I mean, I totally get that you're on yours, but I can't, because then if I allow you, I have to allow everybody else. I don't play the favoritism game. Yeah, it's either yes or no. It's either a yes or a no. Before you sit down, grab your papers. Here's your stuff from yesterday. Here's Sissy's stuff from yesterday, and I'll give you the rest of her stuff for this week today too. Because she's not coming back till Tuesday, right?
Yes, sir.
Yes. Are you gonna see Chelsea today? For some reason, I forgot to give her this paper from today. I gave her everything else, but I forgot to give her that one. Please tell her I'm thinking about her and eat lots of pudding. Pudding's good when you have listen to that. Oh, that would be good. It's soft. Aww. Okay. B, Daniel, is this direct variation or not?
Yes.
He says yes. How many of you agree?
Yes.
What's my constant of variation then, Brandon?
I don't know. I'm gonna aim for that one. I didn't want to put it on the
Negative 3.5.
Okay. C, let's see. Justin, is C direct variation?
Oh, no, it's not.
No, it's not. Okay. If you do the first one, you get 0.75. If you do the second one, you get 3. Okay. So right there, as soon as you get a constant that's not the same, you know it's not. Okay. Finally, my last one. Let's see. Delicia, you said yes. Good. I agree.
It's like 16. It's like.
It's 0.06. Good, Rebecca.
2.5.
2.5.
Yeah, I did.
6.25. Victor, here's this. All right. So let's scoot over to with an equation. A direct variation can be written as an equation in the form y equals k times x, where again, k represents your constant of variation. Okay. So before you can identify any of these, it must be equal to y. Okay. And remember, we said if there's anything added or subtracted, automatically no. If there's no number, okay, that's even an unwritten 1 in front of x, then it's a no. So if I have like y equals 2, that's a no. I have to have y and I have to have x for it to be direct variation. Do you have a question, Kate, or are you just stretching?
No.
Okay.
So would number 1 be no?
So number 1, do I have anything added or subtracted?
No.
No. Is there a number in front of x?
Yes.
Yes. So this is yes. And k would equal 6. Take a look at number 2.
No.
No.
That's a no.
There's a y-intercept.
You've got a y-intercept that's not 0.
Yes.
Number. Letter C. Muhammad said yes. What's my k value, Emma? There's so many Emmas in here. Okay, what's wrong with D? It has to be equal to y first, so I have to do division.
And then it would be y equals 2x.
3. So I get y equals 2x. So we would say what, Lauren? Is this direct or not? It is. And Jocelyn C, what's my k value? 2. Okay, E.
Yeah, you gotta divide.
I gotta divide again. By 5. So y equals 1/5 x. So, Quentin, would you tell me yes or no? Is E direct variation or not?
No.
I put yes.
Yes.
I put yes.
That should be a yes. You looking at the right letter? E. You get y equals 1/5 x when we solve for y. So there's nothing added or subtracted, and there's a number in front of x. Okay. So this means yes. And k equals what, Mo? 1/5. Okay. Again, it doesn't matter if it's a fraction in front of x. It does not matter if it's a negative in front of x. Okay. As long as there is a value in front of x that gives you a slope, you're good. Okay. Victor, I need to solve this one for x. What's the first thing you want to do?
Get the 5y by itself.
Get the 5y by itself. So I need to do what then?
Add 15.
Fantastic. I'm adding 15x to both sides. So 5y equals 15x. Okay. My next step, Rebecca, then is to do what? Adding or subtracting a constant. Okay. I need to divide. Okay. Perfect. You're fine. Y equals 3x. Okay. So, Shania, would you say that this is direct variation or not? Absolutely. Good. What's my k value here? Allison. 3. Okay. This one Brandon has said already. It's a no. Now, because you have a number without the y or x, Rebecca, this is where it's going to tell you ain't going to happen. Okay, because if you would actually solve this one for y, we subtract x, so you get 3y equals 9x minus 6. When I divide everything by 3, y equals 3x minus 2. That minus 2 automatically tells me, nope, not going to happen.
That's a linear function. Remember that?
Okay. Questions on equations. Okay. My last one. Direct variation with a graph. The graph of a direct variation is always a straight line. We said it's a linear function, which makes it a straight line that goes through the origin. Good. Okay. There is no y-intercept besides 0. It must go through the origin. Okay. So we're going to go back to, what is the 7th grade where you learned how to graph? 8th grade? All right.
Wait, 8th grade or what?
Where we learned how to graph? Okay. Either way. Okay. So each one of these graphs should start at the origin. Before I can graph, it must be equal to
0.
y, which is technically 0. Okay. I'll roll with it. Okay. So slope. Rise over 1. Blech. Rise over run. Okay. So here it's a 3. So that means 3 over 1. Positive 3 moves us up. Positive 1 moves us to the right. So from the origin, I've got one that goes up by 3 and to the right by 1. If I want another point, I can do what too?
Up by 3 over 1.
But I go off my graph. So how do I go backwards? Down by 3 and to the left by 1. Okay. Remember, you can go exactly the opposite. Okay. Y. I've got negative 1/2 x here. So negative 1 tells me I'm going down. Remember, rise over run. So it either goes up or down first and then left or right second. Positive 2 to the right. So down by 1 and to the right by 2. Or I can go opposite, which is up and to the left. Oh, that's an awful line. I totally missed my point. I apologize. That's awful. Okay. Letter C. This isn't equal to y, so I have to do what first? Divide by 3. So y equals 2/3 x. So that means my slope's going up to the right by 3. Or down to and to the left by 3. Okay. Letter D. I have to do what first? Divide by -4. So I've got y equals -1/4 x. So I can go down by 1 and to the right by 4. Because you're dividing by a -4. So I can go down by 1 and to the right by 4, or Kenzie said up by 1 and to the left by 4. Okay. It doesn't really matter which number the negative goes with. So you could have left it +1 and -4, which would have moved you up and to the left. Okay. As long as you keep it negative. Okay, so the negative has to go with one or the other. Okay. The last one down here. Write an equation for the direct variation graph below. So it's going to be y equals something x. I need to first find my slope. My slope goes up
Over 2.
and over 2. Okay. 5 over 2.
So could you make it to y equals 5x?
Could you do what?
Can you make it to y equals 5x?
Yes.
Just for okay, cool. That's
And
what
that would be the same equation.
all right, yeah, that's what I did.
Okay. Questions? That glues in on page 93, my friends.